Hi everybody. Welcome back. We are again talking about rational functions and asymptotes, and now we are going to talk about this other type. So basically, how you find these other types. So this other type only occurs when the denominator or the degree of the numerator is higher than the degree of the denominator. And to find this other type of asymptote, unfortunately, polynomial long division is required. So let's look at example 1 and see how we figure this out. So we set up our polynomial long division. So we'll have x squared plus x plus 1 divides into x cubed plus x squared plus x plus 8. So x squared goes into x cubed x times x squared is x cubed, x times x is x squared, and x times 1 is x. Then we subtract that off, and because of the nice design of this problem, all those terms cancel. And we can just bring down the 8, and x squared doesn't go into 8, so 8 is the remainder. And so our asymptote then is going to be, let me get a different pen here. We're going to take our quotient here and just write y equals x. So that what this means is when I draw my graph here, as I get large and small values of x, they're just going to start looking closer and closer to being like this line here. So we'll see it when we do an example. Right now we just want to figure out how to figure this out, what the equation is, and then graph it later. Notice that this is degree 1. And degree 1 asymptotes here are usually called slant or oblique. So just be aware, if I slant or oblique, that would mean that we should get a line as our asymptote here that is non-horizontal or non-vertical. So let's look at another example here and see the fact we can get some weirder asymptotes than this. So here's my other example. Again, polynomial long division is needed, so x plus 1 divides into x cubed plus x squared plus 3x plus 1. And so x goes into x cubed, x squared times, so we'll get an x cubed and a x squared. I'm subtracting those. We end up with 0 and 0, so the 3x comes down. And we also bring down the 1 here, because since this is a binomial term, we need to have at least 2 terms down here when we are figuring out this problem. So x goes into 3x 3 times. So 3 times x is 3x. And 3 times 1 is plus 3, so we're going to subtract that, and notice that we get 0 for this column, so they cancel, and we just get a minus 2 here. So again, this is going to be our quotient, so our quotient is going to be y squared plus 3. And this is our asymptote, and this is called a nonlinear asymptote because this is an equation of a parabola. So in our next 2 videos, we're going to be working on graphing these now that we know what asymptotes are and how to find their equations. And then finally, we'll talk about inequalities. So we'll see you then.